In cognitive science, we call this localization of function, which is just a really fancy term to say some parts of your brain do some things more than others. And feel free to actually touch your head as I go through this, because I think it's really neat to be able to be like, oh wow, this part of my brain does this. So if you are looking at the screen and you touch your forehead and that kind of part of your brain, not your brain, your head rather, this is called the frontal lobe because it's in the front. And this is where your problem solving, how you plan, a lot of your personality comes from this. Emotions, executive functions are like your day to day, how do you survive? And this is the part of the brain that develops slower. So your frontal lobes are a lot less developed than they will be in 12 years when you're 25. And around at age 25, this part of your brain will be fully developed and fully functional. This is often why people will be like, oh, teenagers don't make the best decisions. And then scientists will say, well, they don't have that part of the brain completely done yet. That makes sense. Moving back from the frontal lobe, so now we're kind of a third of the way above your head with the motor cortex. A lot of your muscles have these nerves that were wired to the motor cortex. And this is how you move, how you pick up touch. And that's why the sensory cortex is right behind it, and that's sensations. How do you process smell? How do you process touch? All of these different things are kind of part of this middle top part of your brain. And it's all about movement with the motor cortex. I want you to think motor is like a movement. Sensory is touch, smell, taste. That's the part of the brain kind of directly right on top. And if we go 2/3 of the way back, but before we get to the very back, you get what's called the parietal lobe. This is where you make sense of the word perception. So the back of your brain, your occipital lobe, will give you vision, or give you eyesight, or do all this cool stuff. But if you don't know how to recognize that a dog is a dog, you would be like, I see this four-legged thing, and not make any sense of it. The parietal lobe communicates with this part and goes, oh, that four-legged thing, we've seen that before. What's it called? Oh, a dog? Okay, that's what a dog is. And that's how you can make sense of the world around you. Also, some basic spelling, math goes on here. Our occipital lobe, which is the way, way back, so you kind of just put your hands up behind your head like you're taking a nice, deep breath. That's our occipital lobe. That's going to be all your vision and all that kind of stuff. That's also why football players, sometimes they'll get hit from the back and say, oh man, I saw flashes for a little bit. Literally, the brain, this part of the brain responsible for vision, got whacked on the football hit, and that causes all the different, I can't see, or that kind of temporary flash. Now, if you put your finger on your temples, which is the side of your heads, this is called the temporal lobe. I kind of think it as people say oh, this is the temple, right, near your ears, kind of. And that's where you're going to have memory, understanding, and language. A lot of the parts of the brain that deal with making sense what you just heard, that kind of stuff happens in the temporal lobe. What's interesting is there's this famous story about a man named Phineas Gage, and he had a railroad spike. There was some accident, and it went through his brain right here, through the frontal lobe. And based off what we talked about, what do you think happened? What happened to his frontal, or to his brain overall, if he just had a giant metal spike through a freak accident, boom, goes through his head, and he survived it? What do you think would happen? So what happened to Phineas Gage was only his frontal lobe was really affected. So he could walk, he could still feel things, he could make sense of the world around him, he could see fine, he could hear, he could remember a lot, but his personality changed. How he solved problems and his emotions and behavior deeply changed. So he went from a very likable, calm man to one that was incredibly known for his anger, one that was known for being like just full of outbursts. And that's why people will say the localization of function. Each function has a local part. And this isn't completely true, but for the top of your brain, with these 4 or 5 major categories, it tends to make sense. So we know that brains super connected with electricity. They're super tied together in these like interconnected webs of vines, and what's going on there? You may have heard of some of these. Some people say like, oh man, the dopamine or glutamate is sometimes in food, but in different formats. Basically, if this is one brain cell, or also known as a neuron, connected to another brain cell, and suddenly you're in danger. My goodness, I'm in danger. Your body starts to produce some kind of like, your heart starts going, everything. What causes that? And people say like, oh man, I want my adrenaline rush from like hiking Mount Everest. Is your brain sending this chemical all throughout the chain? So this neuron will be like, we're in danger, send the signal. Next neuron gets the signal and it's like, we're in danger, pass it on. And it just gets passed on from cell to cell to cell until it gets to where it needs to be. And then there'll be neurons that will tell your heart, I need you to pump faster, I need you to get those lungs going, we need to take deep breaths. There'll be another part of your brain that will tell, hey, we gotta move or we gotta fight. Like, we need to fly out of here and run, so let's get those muscles ready. Or, you gotta get ready for a fight, so prepare to take some damage. Some other famous ones is serotonin is for mood. So you see this with a lot of people who can't sleep at night and kind of are a little upset. Serotonin is potentially an issue. If you've ever had like a exercise or played like sports and afterwards you feel like exhausted, but then weirdly like an hour later you just feel like $1,000,000, even though like an hour ago you were like, oh my gosh, I can't feel my legs, like, oh my gosh, my arm hurts. But then like 30-40 minutes later you're like, whoa, I feel great, what's for dinner? That's called endorphins. And they're kind of like this sensation of complete happiness and like relaxation. There's a few other ones. Dopamine is anytime you get a reward, you make money, you get a gift, you get like a dopamine response, which is why you feel happy a lot of the time. Noradrenaline, and acetylcholine, these two, are really big in school with concentration and learning. When you learn something new, a lot of the time there's a lot of acetylcholine that gets released as you learn new information. So this is a brief introduction to how your brain works, from what are the cells that make up it and how they use electricity, how do your eyes work and like how is your brain basically wired, what parts of your brain do different things, and then finally, how do cells in the brain communicate? And it's quite crazy that their brain cells legit have all these chemicals, and when they need to release them, they just send them out to the other brain cells, and then they all start to tell each other what's going on through these rough amount of chemicals. In the future, we're going to dive a little deeper into the brain. I'm going to bring up a few really interesting case studies, some cool brain science and psychology, and some more really crazy science. I hope you enjoy.